Let's take out, are we on? Let's take chapter 16. Now, this is the properties of solutions. Now, in chapter 15, we looked at how solutions form. We looked at homogeneous combinations of material instead of homogeneous material. What's the difference between a homogeneous material and a homogeneous combination of materials? Anybody? Jen, you have something on the tip of your tongue. Say it. It's okay. The worst thing that's going to happen is you're wrong. What do you want to say?
Well, homogeneous material is one material and it's consistent all the way through.
Yeah, a homogeneous material is one material. In other words, what are the two types of homogeneous materials? Compound or element, right? What's another name for a homogeneous material? Starts with an S. Long word, one word, starts with an S, homogeneous material, or starts with an S, or you can do this. This is my quiet class, a little zombie-like. They all have the word on the tip of her tongue, but they're afraid to say it because they don't want to be wrong. Anybody want to say it? I need some markers. My kingdom for some markers. Anybody want to say it? No? Substance. A substance, right? How many people knew that? Raise your hand. Okay, we have four people that raising their hands, so 4 people knew it. No one was brave enough to say it out loud. Now, you take 2 substances and you put them together, like sodium chloride and water, or potassium nitrate and water. Those are 2 substances homogeneously combined. That's a solution. A colloid is really homogeneously combined, but it's considered heterogeneous because the particles of a colloid are very easily detected by what process, what effect? The Tyndall effect. So even though a colloid is completely mixed, it's considered heterogeneous. And that's because of the size of the particle. A suspension is something that's eventually going to fall out. What can stabilize a colloid? In other words, what does it mean to stabilize a colloid? What does it mean to stabilize a colloid? It means you prevent it from clumping, you prevent it from falling out, where things clump and they become so big and they fall out. What's the name of the thing that stabilizes a colloid? It starts with an E. Emulsifier. You make an emulsion, correct? An emulsifier. What type of colloid usually uses an emulsifier? A liquid, right? Where the liquid is the dispersed medium. In other words, what do I mean by dispersed medium? Is that analogous to the solute or the solvent, the dispersed medium? That's analogous to the solute. The dispersing medium is analogous to the solvent. I should get more money to teach this class. I have to do more work in here. Do you know that? I'm more exhausted after this class than any other class. You should stand up here with me and watch everybody. I don't get answers from you guys. Okay. So what we're going to do in chapter 16 is we're going to concentrate just on solutions. I would say, in terms of the video that I'm making for the lecture on chapter 15, the topic I covered most would be colloids, because I knew you weren't going to get it anymore. The second major topic I covered was solutions, which I think is fairly easy. What's the number one thing that you have to understand when you're talking about solutions? And what the kind of solutions we're going to talk about are solid dissolved in a liquid, mostly. Little gas in liquid, but mostly a solid dissolved in a liquid. Correct? What's the liquid going to tend to be? You've seen it in chemical reactions that I write this year. You see this. What does that mean? It means aqueous, but what does aqueous mean? Water solution. So if most of the solutions we're going to work with are solid in a liquid, and the liquid is water, what would you need to know most of all about solutions, solution chemistry? What makes things dissolve in water? Throw some words out. What makes things dissolve in water? You want to put that away? What makes things dissolve in water?
What do you mean? You mean speed up the process?
What makes it? What's the theory? What drives the process of dissolving? All right, throw a word out. Temperature, I like that. And how does temperature work? Liz, how does temperature work? It makes things move fast. It's like, what's the difference between amateur baseball and professional baseball? What's the difference between amateur soccer and professional soccer? What's the number one difference? Speed, right? Everything comes at you very quickly, extremely quickly. Yes? I worked in a summer camp once, and a fellow by the name of, he pitched for the Boston Red Sox and the Mets. His name was Mike Torres, and he would come in, and I tried to hit against him, and he would throw a ball, not very fast, but it made a lot of movement. And God, I played Little League and things like that, but this ball was like screaming right at me. It was unbelievable. And he threw it with such fluidity, but it was speed. The difference between amateur sports and professional sports is one word, and that's called speed. And what does temperature have to do with speed?
Speed. It provides more kinetic energy.
It provides more kinetic energy. The temperature is heat. You know, it's because you're adding heat, you're adding kinetic energy, you're increasing mechanical energy, correct? So temperature is good. What else about solutions? Yes?
Agitation.
What is it?
Agitation.
What is it?
Agitation.
Agitation. Okay, you're stirring it.
Yes.
How do you spell agitation?
A-G-I.
A-G...
I.
Yeah?
T-A-T-I-O-N.
You had to look that up, didn't you? Everybody wants to put a D in there. Agitation. Okay, what else? So that has to do with agitation, temperature. You're making things move more quickly. Yes? Yes, Liz.
Particle size of the.
Particle size. What does that mean, Liz? What does that mean, particle size?
I guess like whether it's.
Like a chunk?
Like a chunk, yeah.
Like a chunk of sodium chloride, or you grind it down, right? Correct? So what, if you grind it down, what are you increasing? You have this block. Here I have this block of sodium chloride, right? Is that going to dissolve quickly? Giant block. So what do? I do what? I grind it down. And what is the grinding down going to do for me? Yes?
Increase the surface area.
Excellent. Excellent. You're going to increase the surface area. And that's what this really means. You're going to increase. That means as the plot thickens, increase surface area. Excellent. What else about solutions? What else about you have to know about water? How does things go into solutions? Anybody? What's something you really have to know a lot about? Yes? Ionic. Ionic. Just the word ionic, powerful, isn't it? What's the number one intermolecular force? Ionic. Cool. Ionic. What else do you have to know about? You said it. Polarity is very important. Yes? I'm going to put it in my lecture, but you can look it up right now. What measures polarity? What are some things that you could actually do in a laboratory? Mohammed and Kamal, they look so incredibly studious. I can hardly I can hardly think straight while looking at them. They have these laptops open. I'll ignore the fact that they're looking up the latest soccer scores, but they certainly look like they're doing what they're doing if we assume they are being wonderful children. Why don't you guys look up how polarity, how is that measured? How is the polarity of a solution actually measured? What numbers can we actually attach to that? Okay, why don't you look that up and give us a report in about 10 minutes or so, okay? Would you do that? Excellent. So, polarity, ionic, excellent. What do you have to know about polarity? What causes polarity? Polarity of what? Polar bonds? Polar molecules? What are we talking about polarity? What does that mean? Polar compounds? Polar molecules? Yes? What's the number one absolute kick butt polar molecule that you can think of right now? It's the most common. If you didn't have it, you would be dust. That's a hint. And they're thinking. Look at Genevieve. No, she would be number one in the graduating class, competing, of course, with Mountains, of course. And she's like, doesn't want to say it. She knows this. She said it, but she whispered. All right. Excellent. Say it with authority. Saying like you created it. Say it. She thinks I'm crazy. She just doesn't want any part of this. It's water. Water. Okay? So it's going to be H-O-H, water. We've talked about water ad infinitum. And what aspect of water makes it so important relative to solutions? Give me some words to describe how water affects the dissolution of material. Yes?
Hydrogen bond.
That's 2 words, and I like that. I think of it, it's so important, let's give it a promotion. Let's make it 1 word, okay? I mean, it's just too important to separate, okay? Hydrogen bond, right? Hydrogen bond. Let's call it, from now on, we'll call it HB. Yeah, hydrogen bonding is the number one important aspect of all solution chemistry. Because most of solutions that we will deal with, especially as young chemistry students, the solutions that we deal with are aqueous solutions. It was up here. And you're using water. Hydrogen bonding. Polarity, ionic, agitation, temperature, particle size, surface area, these are all important. But please don't misrepresent the following. The hydrogen bonding that water can do is the critical element. Let's say we have a particle of salt like this. Well, if you increase temperature, you're increasing agitation. These molecules of water are hitting the salts, and you're breaking it apart. And then you're solvating. What does that mean, solvating? Not salivating, Kamal. I didn't say salivating. I said solvating. What does solvating mean? He really didn't say that, but I wanted to get his attention. What does it mean if you solvate something? You're going to put, let's say you're going to take this sodium, and you're going to, that's the oxygen, right? Right? This looks like this, right? That's hydrogen, so that's going to be a partial positive. That's a partial positive, and this is 2 times a partial negative, right? So it's going to go like this. You're going to solvate that sodium. You're going to surround it. Custard's Last Stand. The Battle of the Little Bighorn. What is that? What's a Little Bighorn? What is that? What is it? It's a place? How many Americans in here? 3, and you don't know what the Little Bighorn is?
I know it's like some type of battle, yeah.
It's a battle, okay, but what does it mean, Little Bighorn? What does that mean?
It's a horn that's little and big.
It's a horn that's both little and big.
It could be.
What is the name of the battle named after?
The Battle of the Little Bighorn.
Thank you very much. But the Battle of Little Bighorn. But what is it named for? The river is called the Little Bighorn River. I've never been there. Okay. So it's surrounded. It's solvating. Okay? Chlorine would be surrounded like this. Okay? Would it be surrounded like that? Yes? So the water, now remember we studied charges, we studied atomic theory. Let's review for the chemistry exam in 5 or 6 sentences or less. This is your review for the exam. Are you ready? I'm going to review for your final exam right now. You ready? Okay. We studied atomic theory so that we could give charges and understand the valence structure of hydrogen and oxygen. True or false? True. We understand that they have oxidation state. True or false? +1, -2. We know that the formula for water is H2O. True or false? True. We know where those elements are placed on the periodic table. True or false? True. We know that the molecular structure of the formula H2O is a bent molecule with 2 unbonded pairs of electron on the central atom called oxygen. True or false? We know that the bonds that make up water are polar. We know that because of the irregular shape of water that it creates a polar molecule. Correct? True or false? We understand that that polar molecule, when combined with ionic compounds, will solvate them. We just reviewed 5 or 6 chapters. True or false? True. Yes? Water. Very important. Okay? Yes? Solution chemistry part 1. We're done. Clear? Was that good? I kind of set the stage, a little bit of an introduction. I'm going to stop, write some formulas on the board, and we're going to start some calculations. Good? Cool? Are we there? Excellent.